What I want to do in this video is to explain the different kinds of relationships between two events. In particular, I would like to talk about mutually exclusive events, complementary events, exhaustive events, and independent events, and their mathematical meanings. Some people might find them confusing in the first time they learn this, but it's important to clear up these concepts because you might see them quite often in your statistics class or in probability problems, etc. To start with, let's talk about mutually exclusive events. Mutually exclusive events are events that could not happen at the same time. Events that could not happen at the same time. Let's look at some examples. For example, when we roll a dice, the events that we roll a 4 and the events that we roll a 5 in a single row are mutually exclusive because we cannot get both a 4 and a 5 in a single row. We can only get one number. So, the event that a 4 is rolled and the event that a 5 is rolled are mutually exclusive events. And another example is that I got an A in a maths exam, and the events that I got a C in the maths exam are mutually exclusive because I cannot get both an A and a C at the same time, so they are mutually exclusive events. And the mathematical meaning of mutually exclusive events is that the probability that event A and event B occurring together equal to 0. Now, let's talk about complementary events. If two events are complementary events, they are the only two possible outcomes. So they are events that are the only two possible outcomes. In fact, complementary events is a kind of mutually exclusive event because the two outcomes cannot occur at the same time. So if event A and event B are complementary, then the probability of A and B occurring together is also equal to 0. But the difference is that if two events are complementary events, they are the only two possible outcomes of an event. But if they are mutually exclusive events, they might or might not be the only two possible outcomes. So let's look at some examples if this sounds too abstract. An example is that, let's say we have a bag, and inside the bag we have a red ball and a green ball, and we are to randomly draw a ball from the bag, so we can either get a red ball or a green ball. So the events that a red ball is drawn and the events that a green ball is drawn are the only two possible outcomes, and they are known as complementary events. Let's look at another example. Let's say that we are flipping a coin. When we flip a coin, we can either get a tail or a head. So, the events that the head is flipped and the event that the tail is flipped are complementary events. So, let's now talk about the mathematical meaning of complementary events. If two events, events A and event B, are complementary, then the probability of A plus the probability of B happening equal to 1. And then let's talk about exhaustive events. For exhaustive events, at least one event in the set of events must occur. So at least one event in the set of events must occur. In other words, the union of the two or more events governs the sample space. Let's look at an example. Let's say that every student in the school must join at least one sports team of the school. So for simplicity, let's say that there are only two sports teams in the school: the football team and the basketball team. So, a student in the school must have joined either the football team or the basketball team or both. And the events that a student has joined the football team and the events that a student has joined the basketball team are exhaustive events. So, let's talk about the mathematical representation of exhaustive events. For exhaustive events, the mathematical meaning of exhaustive events is that the probability of event A union event B equal to 1. Last but not least, let's talk about independent events. For independent events, the occurrence of an event does not affect the probability of the occurrence of the other event. So, the occurrence of an event does not affect the probability of the occurrence of the other event. Let's look at an example. So, let's say that Justin and Mary are two students from a school, and that Justin travels by bus to school on a day, and that Mary goes to school on foot on the day are independent events. So the events that Justin travels by bus to school and the events that Mary goes to school on foot on the same day are independent events because how Justin travels to school does not affect how Mary travels to school, so they are independent events. The mathematical meaning of independent events is that the probability of event A and event B happening together is equal to the probability of A times the probability of B. And this is also known as the multiplication rule of probability. The multiplication rule of probability. Some beginners may sometimes easily get confused with independent events and mutually exclusive events because it's kind of intuitive to have a sense that independent events means that the two events are not related to each other. And if two events are not related, they would be like separate like this in a Venn diagram. It's as if a child being independent from his parents would be like being separate from his parents. However, if you think more carefully and don't jump into conclusion just by intuition, two events being independent does not imply that there's no intersection between them. They can still happen together. Let's look at the last example again. That Justin travels to school by bus on a day, and that Mary goes to school on foot on a day are independent events. But two events can still occur together, because it's possible that Justin travels by bus to school on a day, and Mary goes to school on foot on the same day. Therefore, two events are independent events given that the occurrence of an event does not affect the probability of the occurrence of the other event, but they can still happen together. So the Venn diagram representing independent events can also look like this. There's an intersection between them. So in fact, what this diagram represents is mutually exclusive events. Mutually exclusive events are events that could not happen at the same time. Therefore, the two events have no intersection. They cannot happen together. For example, the circle on the left may represent that I got an A in the math exam, and the circle on the right would represent that I got a C in the math exam. The two circles would not intersect because I cannot get an A and a C at the same time. So, hopefully you're now clear about the difference between independent events and mutually exclusive events. In the next video, we're going to do a couple of examples using the mathematical representation of the types of events.